Let's talk about simplifying rational expressions. So I guess the place to start is, what is a rational expression? A rational expression is anything that looks like a fraction, but instead of numbers, it's polynomials. So it's something like f of x over g of x, where both f of x and g of x are polynomials. So an example of that would be x squared minus 5 over x cubed plus 3x minus x squared. Sure, that's one. Or x over x squared plus 8. That's another. Anything where on top it's a polynomial and bottom it's a polynomial is a rational expression. This video is about how to simplify rational expressions. This video is like if fractions and factoring had a baby. Because to simplify a rational expression, my first step is to factor the top and factor the bottom. In this one, factoring is going to be much more pleasant than it sometimes could be, because these are both quadratics with a leading coefficient of 1. When it's a leading coefficient of 1, I know it's the easy version, where I just need to think about what multiplies to 14, adds to negative 9. That's going to be negative 7 and negative 2. And for the bottom, I think about what multiplies to negative 8, adds to positive 2. That's going to be minus 2 and plus 4. Once it's factored, before I simplify it, I take note of what x can't be. That's what this means when it says state the values excluded from the domain. Domain is things x can be. So I need to think about what can x not be. The rule is I can't be for fractions is I can't be 0 in the denominator. So any zeros of the denominator have to be excluded from the domain. X can't be 2 or negative 4. If I try plugging 2 or negative 4 in, I'm going to get something over 0, and that breaks a math rule. I'm not allowed to divide by 0. So when I say the values excluded from the domain, in this case it's going to be 2 and negative 4 are excluded from the domain. Now I can move on to the simplifying. Simplifying happens by canceling common factors. On top, there's an x minus 2. On bottom, there's an x minus 2. So my simplified answer is going to be x minus 7 over x plus 4. I can only cancel things that are common factors, things that I see it in parentheses on top and in parentheses on bottom. Let's try another. Here, I factor it. I have a GCF on top and bottom. I have a GCF. So I could take a 3 out on top, and that leaves behind x squared minus 3x minus 4. I could take a 6 out on bottom. And then I can factor those even more. I have 3 times x minus 4, x plus 1, over 6 times x squared minus 1. And you know what? I could factor x squared minus 1 even further. This is going to become 3 times x minus 4 times x plus 1. The top is as factored as it can be, but the bottom, x squared minus 1, I could do a little difference of squares, turn it into x minus 1 plus 1. So now, before I actually do the problem, I'm going to think about values excluded from the domain. So things x can't be, things that'll make the denominator 0. Things that make the denominator 0 are negative 1, 1, and 0. Those are the zeros of the denominator. So my values excluded from the domain are 0, 1, and negative 1. Sometimes teachers are picky and want you to write it in number order. I'm not picky. Now I can move on to simplifying. Simplifying happens by canceling common factors. I see x plus 1 on top. I see x plus 1 on bottom. Those cancel. The numbers also can cancel. If I had a 3 and a 3, I would cross them both off. 3 and a 6, I know what 3 over 6 turns into. 3/6 is the same as 1/2. That means that this is going to turn into 1 times x minus 4 over 2 times x minus 1. In other words, it's x minus 4 over 2 times x minus 1. We're on such a roll. Let's keep it going. Here, I think about factoring the numerator and denominator. The numerator it's backwards. I don't like things that are out of standard form. I'm just going to, before I even worry about factoring, I'm going to rewrite it like this. I'm careful to keep the minus sign with the x, and it was a positive 2 here, so it's going to be a positive 2 here. Now that it's like that, I'm going to be able to factor it. The bottom, I instantly recognize difference of squares. X squared minus 2 squared, it turns into x minus 2, x plus 2. The top doesn't really factor. I have a personal rule that if I see a negative at the front of the thing I'm factoring, I take out the negative. That's a good rule because then I can see things canceling here. Before I see the things that cancel, I'm going to think about the values that are excluded from the domain. Those are the things that are the zeros of my denominator. The zeros of my denominator are 2 and negative 2. So when I'm asked what values are excluded from the domain, I'll write negative 2 and 2. And then I simplify by canceling out my common factor. So I cancel out that x minus 2, and that leaves me with an x plus 2 on bottom and a negative on top. Well, no, this negative really means it's negative 1 times this. So I'm really left with a negative 1 on top. That's what it simplifies to. Keep it going. Ooh, this looks like a beast, but it's not really because there's a GCF I could take out of everything. X squared comes out of the top. I'm left with 2x squared plus 9x minus 5. X comes out of the bottom as a GCF. 6x squared plus x minus 2. And now those quadratics probably factor more. I'm going to just go to the side of my paper and think about 2x squared plus 9x minus 5, how that will factor. I'll factor that by doing 2 times a negative 5 equals negative 10, and I look for things that multiply to negative 10 and add up to positive 9. So that's going to be 10 and negative 1. I use those numbers to rewrite my expression. I rewrite it as 2x squared, and I use the two numbers, positive 10x minus 1x. I replace 9x with positive 10x and minus 1x. I then do a little factor by grouping. This turns into 2x times x plus 5, negative 1 times x plus 5. So I have a 2x minus 1 and an x plus 5. My numerator factors to 2x minus 1 and x plus 5. And I don't forget about that x squared that I already had. Then I think about the other part, the denominator. If I have 6x squared plus x minus 2, I factor that by doing 6 times negative 2. You get negative 12. What multiplies to negative 12 and adds up to positive 1? That's going to be positive 4 and negative 3. I use those numbers. 6x squared, positive 4x, negative 3x. I draw my curtain for factor by grouping. I do take out my GCFs. And it looks like it turns into 2x minus 1, 3x plus 2. My denominator is the x that was already there, along with a 2x minus 1 and a 3x plus 2. These I could put in parentheses. They're multiplied to the other things, so I could put them in parentheses. And the reason I'm doing that is because I just am keeping in my head, oh, I was told I only cancel things in parentheses, only factors. So if I put everything in parentheses, that's a factor. Every multiplication, I write it as parentheses times parentheses. Then I'll be able to see things canceling. Okay, first off, what are the values excluded from my domain? Values excluded. Those are the zeros of the denominator. 0, a half, negative 2/3. Those are going to be the values excluded from the domain. Now I go ahead and I simplify this. 2x minus 1 on bottom, 2x minus 1 on top. X on bottom and x squared on top. Maybe you look at that and you're instantly like, oh, x squared over x, that's just x on the top. Because, x squared over x, that's like x to the 2 over x to the 1. X to the 2 over x to the 1 turns into x to the 2 minus 1, so it turns into just an x. Or maybe you're better off thinking about it as super factor out. Be like, okay, I'm left with x times x. That's what x squared means. So then you cancel some x's, and you're left with x times x plus 5 over 3x plus 2. That would be what this simplifies into. Again, the other way to do it would be to look at this x squared over x and be like, well, x squared over x, that's the same as just x over 1. So we ended up with an x over 1. We'll do one more. Just, it's bad luck to stop at 1, 2, 3. It's bad luck to stop at 4. It's always good to stop at 5. That's an ancient tradition in my culture. So let's factor. The numerator, oh goodness, 4 terms. Oh goodness. Well, I hope factor by grouping works. If it doesn't, I can still do rational root theorem, plug in. It's just going to be a long process. So I'm hoping that this will factor by grouping. It'll just be a little bit faster than if I have to do something longer. I draw it out. I draw my little factor by grouping curtain. On the left, I could take out an x squared. That leaves me with x plus 4. On the right, I could take out a negative 9. That leaves me with x plus 4. Happy birthday to me. I have x squared minus 9 times x plus 4. Does this factor more? Yeah, x squared minus 9, that's the difference of squares. X squared minus 9 is x squared minus 3 squared, so I'm doing x minus 3, x plus 3 times x plus 4. The top factors 2x minus 3, x plus 3, x plus 4. On bottom, I have a GCF I could take out. On bottom, I could take out a 4. I'm left with x squared plus 7x plus 12. I may or may not have spent about 8 minutes doing this problem with it factored wrong. I had to re-record it. Does the bottom factor more? Yeah, the bottom factors more. The bottom is going to factor into a 4 times x plus 3, x plus 4. Where did I get that from? I got that from, obviously, you know where I got the 4 from. And then I thought about what multiplies to 12 and adds up to 7. And I decided, oh, that's 3 and 4. Because it's the easy version of quadratic factoring where there's no leading coefficient. I just had to fill in the two numbers, x plus 3, x plus 4. And the top was already as factored as it could be. So now, what are my values excluded from the domain? Negative 3 is one of the zeros in my denominator, so it's excluded from the domain. If I plugged it in, it would make something divided by 0, so that can't happen. Negative 4, I'm not allowed to plug in for x. It's a 0 of my denominator. If I plug it in, I get something over 0. Can't happen. These are the two values excluded from my domain. Now I move on to simplifying. I have an x plus 3 and an x plus 3. I have an x plus 4 and an x plus 4. Oh goodness. That leaves me with just an x minus 3 on top and a 4 on bottom. That simplified kind of nicely. Alright, 5 examples. That's the proper number. Good luck.